Receiving incoming transmission.
Incoming transmission.
Incoming transmission.
I'm sure you have many questions.
Transmission.
Transmission.
Welcome to Transmission, a weekly show about the most impactful posts from our Meteor.js forums. My name is Ben Strahan, developer at OKGrow, and each week I am joined by Sashko Stubailo, a core developer at Meteor Development Group. Please note, the contents of this show are the sole opinions of their authors. This show is sponsored by Meteor Galaxy Hosting, a containerized cloud service specifically designed and engineered for Meteor app deployment. Learn more at meteor.com/galaxy. This show is also sponsored by OKGrow, an official Meteor consulting partner building full stack web and mobile apps. Learn more at okgrow.com. Welcome, Meteor fans, to Transmission show number 7. Show number 5 and 6 were insane. Show number 6 was through the roof insane. We broke new records with it, and I am stoked. Even now, I want to say thank you to Matt for joining us and Benjamin for joining us. It was really fun. And a big thank you, Sashko, for setting it all up, man. Thank you so much.
Yeah, man, no problem. Everyone's really pumped to come on the show. You know, I don't even have to work that hard.
Really? Ooh,
yeah, I mean,
that is awesome.
Yeah, I mean, I think everyone has the intention of, you know, saying a lot of stuff and being transparent, but, you know, it's hard when you also have a lot of other stuff to do. And I think for people like Matt, just like being able to just talk about stuff for a while is just so much more natural than having to sit down and write like a long blog post or forum post or something like that.
Yeah. And then just having to manage that. So like people are if you write a forum post, you're going to be on that post for potentially a week, responding to people sporadically, asking more questions. Whereas you come on the show and you just got the questions I ask.
Yeah, and you got the foresight to ask the right questions, right?
I hope so. I don't know. But yeah, totally, man. The community has been supporting us like crazy. Hats off to those guys. Like I am loving this show, and it's exciting just to be a part of it.
Yeah, for me too.
Yeah. So today, we just like talked about how awesome it was to have guests, but today we're not going to have any guests. It's just us two, eh? We're going to be talking about some awesome stuff, though, guys. We're going to be talking about Reactive GraphQL, or referred to as Apollo.
That's the new name.
Woo-hoo. But I want to let you know this is still going to be an amazing talk, even though it's Sashko and I. Like, this is like some serious stuff. This is the future. And then also, if you like guests, we are potentially having a very, very special guest next week.
We'll see. Yeah.
Yeah, I don't know. Because there's so much news going on in the media.
Yeah, no, soon we'll have like Obama and stuff. It'll be great.
Right on. It's good stuff. I think you are going to be super famous in 12 months. So I am really glad that I am doing this with you, because pretty soon the day will come where you are not going to have the time to do the show with me.
No, dude, I don't know. You always have to do fun stuff, right? Like, I just can't imagine. I feel like if I don't have time to do stuff like this, then like I'm doing something wrong. I don't know. Like,
cool. Well, hey,
I just feel like every time, you know, you try to get somebody else to, like, the message never comes across. Like, you have to have such a good messenger to know in depth like everything. Mm-hmm. That I feel like it's easier to just cut to the chase, you know.
Seriously. All right. Well, I hope it stays this way. But guys, I'm just excited about this conversation about Apollo, and that's why I predicted that Sashko was going to be super famous in 12 months. So let's dive into this, man. So GraphQL has a new name, Apollo, and it could go two directions. One direction is it can go the Greek way, Greek god way, which Apollo was the god of many things, and one of it was the god of truth. That kind of makes sense on what we're doing, like managing truth. You know, is your data truthful or not? You know,
right?
And the other one, though, is Apollo, the space mission, where it was the mission to put a man on the moon for the very first time. What was it, man?
You know, I think it's good to keep our options open, because we've been going pretty hard on the space names recently, and I think Apollo is just space related enough that it checks the box and it's consistent, but it also opens us up to, you know, potentially more things. Like, I can totally imagine parts of this adopting the names of other Greek mythology things, or maybe other space things, or maybe things related to various space programs. as well. So I think there's definitely a lot of good stuff right now. Like literally before I came on here to talk to you, we were drawing up ideas for a logo.
I was just going to say that. Like right now, that's the big question. You got a GitHub org, and there's no logo.
Yeah, we were so pumped to get that up that we were like, yeah, whatever. We'll get the logo later. But yeah, I mean, before we can put up a website or anything, we basically have to figure that out. I think this is the new strategy of being as kind of as transparent as possible. Not hold all our cards and then wait until we have exactly the right thing, but just like start putting stuff out there as soon as we have it. And if we want to do stuff like have lots of external contributors, we just can't do that at all anymore, right? Like if you have people outside the building who are helping work on your project, you can't like have secret plans. I mean, maybe like some, but most of your stuff has to be public. Yeah. You can join Facebook if you want to be part of like a secret society, right? They got like those secret hoodies with like secret codes on the back. Oh yeah. Oh, that sounds really cool.
You never saw that video about Mark Zuckerberg like sweating to death on like all things digital or something like that on stage?
No, I'm not as in touch as you are.
No?
I guess.
Oh, it happened like 2 years ago. I'll forward you the video where he's sweating to death on stage. They're like, why don't you take the hoodie off? Like huge armpit stains. He's like, no, I can't. He takes it off and they're like, whoa, what's that in the back? And it's like a secret symbol and he like didn't want to show anyone.
That's amazing.
I'll have to send you that video. Super cool stuff. Anyway, Apollo is the big news. Let's dive into it. To give a big overview, I'm going to attack this as if I totally do not know what GraphQL is. I don't know what Relay is. I heard of them, and we just need a definition for each one so we can like get a context of where we're at, because it's like super complicated what we're trying to achieve.
Yeah, I think the trick is going to be taking all these potentially complicated parts and making it simple, right?
Yeah. So let's dive in. I'm going to be a total newbie, and that way then anyone listening to this will have the right context when we're going forward talking about deeper stuff. So right now we have Meteor, and Meteor is managing everything. It's on the server, it's managing our client, and it's managing the data in between it. It's tied closely to Mongo. Moving forward, things are going to get much more decoupled and separated, it sounds like. Since we know what Meteor is, let's start there. In the future, what is Meteor going to be and what is it not going to be?
I mean, in the context of Apollo, the first thing is Meteor is not going to be tied to Mongo. I mean, that's the number one reason. Mm-hmm. The second thing is we want to make sure that the new Meteor, the different parts that we're working on, you can understand all the different parts, right? So right now, inside Meteor, there are a bunch of different parts, right? There's the oplog tailing that watches MongoDB. There's the way that gets converted into publications that you can subscribe to from the client. There's like certain messages that are sent over the WebSocket to get that to happen. There's mini Mongo on the client that like is actually decoupled from the system, but like pretty hard to remove. And then like there's all this magic that ties it all together. Mm-hmm. And there's not really even a good document or diagram that can explain to you exactly what all the parts are and how you might modify them, switch them out, like use them to your own advantage. Right. And so people like Aeronota, as far as I can tell, they just kind of have to read all the code and do a bunch of debugging to figure out how it actually works, because Aeronota has a bunch of stuff that hacks some of the internals of Meteor to do different things.
Right. And so that's what Meteor is now. And in the future, when we have Apollo and Meteor is going to be using Apollo, what is Meteor going to be then?
Yeah, so I think then ideally you'll still be able to use the system the same way that you always did. You can just have a command to create a new app. But on the other hand, you can also understand what's going on under the hood and optimize that specifically for your case, right? So the thing that reads data out of the database will be its own module that you can use by itself, right? The GraphQL server that takes the GraphQL query.
But that's going to be part of Apollo.
Well, it depends on what you mean by part of, right? So we created a GitHub organization, not a GitHub repo, because we are predicting that we're going to have maybe 20 repositories, maybe 30 under that organization, all with different contributors, different goals, different use cases. and then there's going to be something that ties it all together. Maybe it's even a single package at the end of the day. So we want to make sure that each thing has its own its own tests, its own API, stuff like that.
So what I'm getting at here is we have React or Blaze or Angular. People understand that, and that's going to manage your client, the DOM, okay, and very lightly some state. So, and Apollo is going to be managing the database data and managing the reactivity when that changes and what it should be happening on the client. Okay, we're going to talk more about that later. Put that off to the side. Meteor is then essentially not going to manage the view. It's not going to manage the data. It's going to be a build tool. It's going to be a server-side implementation, right?
So I think Meteor, conceptually, even now, it's just a set of guidelines. Like if you go really abstract about it, right? Meteor is just the guideline that says you should use this package with this other package to put it all together into one thing. Mm-hmm. So at the end of the day, Meteor is just a build tool, a data system, or a UI layer, a mobile build tool, stuff like that. Yep. So Meteor is just the name for the set of those things which work great together. Okay. So I think in the future, when you use Meteor, it'll basically be like you have a starter template for your project, and you have something like the Meteor guide, which tells you how to use all those parts together. Mm-hmm. But it's not clear, like in the long term, exactly how many of those parts are just going to be off-the-shelf components, which you can understand individually, and how many are going to be built by us as glue between those different components.
Okay, great.
And Apollo will be one of the main components there.
Okay, that makes sense. So Meteor is going to be a happy path that for developers, and it's just bringing in and attaching all these parts of the app. But Meteor is like all of that together. Apollo is in on that. Whatever your view layer is in on that. Server, and you keep on tacking onto it. And the build system is going to be able to put all that stuff together, understand it, and make it nice and simple for you. That's what Meteor is going to be.
Yeah, if you think about it, like Apollo is the solution to the data problem that we believe everyone has. We can go more in detail on what that problem is later. And Meteor is the solution to JavaScript fatigue.
Nice. Okay, and so now everyone, I'm assuming, knows Angular, React, Blaze. That's going to be managing your DOM. That's going to be managing your UI. Now we have Relay. What is Relay and what is Redux for people who don't know?
Yeah, so Redux, I think, is pretty popular. I think a lot of people know about that. Mm-hmm. The way I understand it is it's basically a way to have a way of managing some of the state you have on the client in a really easy to debug way. So basically, when React came out, at first there was this idea of putting a bunch of data inside every UI component. So every little UI component would be its own little world. Mm-hmm. But with Flux and Redux, the philosophy now is you really want to have a global place where you can track all of that state and know, like, I pushed this button and that changed my state in this way. And I can debug that. I can do time traveling to go back to the previous state. I can write functions that can analyze it, all that kind of stuff.
Mm-hmm. And that is primarily UI state. And then Relay comes in to manage a different type of state.
Yeah, so Redux people use for all kinds of stuff. I think there's a lot of people out there who do use it to keep track of their server and database state. But I think there's a lot of problems. There's a lot of concerns that arise when you're syncing data across a laggy network that Redux, as far as I know, doesn't help you with as much. You still get some benefits from using it, but it doesn't give you all of the tools you need to load the data from the server. And Relay is Facebook's system for managing a lot of those concerns.
Very cool. Now, will Apollo rely on Relay?
Yes, I think that's the plan right now. The plan is definitely not to take Relay like completely off the shelf and just use everything in it.
Okay.
I've heard that they have some plans to decouple Relay into several components that you can use when you want to. Because the Relay as it is today, if you grab it off GitHub, it's very coupled to React. It's very coupled to a specific router. There's a Relay router. And there's a lot of other things in there too, where it's just one system, kind of like Meteor used to be. where it's all tied together and it works really well together.
Okay.
But what we want to do is open that up to some more integrations, right? For example, like it's a requirement for us that you can use this with Angular 2 or Blaze. Right? And right now it's just not possible with Relay.
Okay. So what part do you foresee that we're going to be pulling out of Relay to use? What?
So Relay, there's this diagram that I really like. It's not really a diagram. It's kind of, you take a diagram of Meteor and you take the diagram of Relay and then you turn one of them sideways and then they're the same diagram. So the funny thing about the Relay system is it has all of exactly the same components as the Meteor data stack does.
Okay.
So it has the server-side connection to the database. It has a cache on the client, which basically stores a local copy of your database on the client next to your UI. It has a way of getting that into your UI reactively. And it has a way of making updates to your data on the server, right? In GraphQL and Relay, they're called mutations. In Meteor, that would be methods, right? Mm-hmm. And it also includes a mechanism for optimistic updates where you update the cache directly and then you update the server. So Relay contains all those components. Right now, I would say they're a little bit more difficult to use than the Meteor equivalents. On the other hand, I think it's a lot more flexible. So it's kind of a matter of taking Relay and making just those components of it that are very valuable accessible through a much simpler interface and one that's also compatible with systems that are not React, basically.
Very cool. Okay. So that makes sense. So then that's a perfect segue to then talk about Apollo. But before that, I kind of want to interrupt and say, okay, so GraphQL, because we got to talk about GraphQL before we can get into Apollo. Relay is tightly coupled to, or requires GraphQL too, I'm assuming.
Yeah, well, the interesting thing about Relay is that if you squint at it a lot, you can imagine a system like Relay that works without GraphQL, right? You could build something like Relay. Basically Meteor you could think of as a version of Relay that just does something totally different, but at the end of the day accomplishes a similar goal. You can imagine a similar system that uses a REST API instead of GraphQL. But you do get a lot of benefits from using GraphQL instead of those other approaches.
Yes.
And in particular, those benefits are the ability to easily compose different data sources, right? That's one thing that Meteor is super bad at because you only really get to use Mongo. Mm-hmm. Otherwise, you have to do some hacks. So composing different data sources is super important. And the other thing that's super important is being able to let your UI components declare their data dependencies, which means you basically need a tree-shaped query language that looks like your UI tree so that you can pass all that information to the server and get back the data you want.
Yeah. Very cool. Which means that you're not going to be making a separate subscription to the users, get the users back, make a subscription to that user's to-dos, and then get the to-dos back, and then make a subscription to the separate tasks under each to-do, and then get the tasks back. Instead, you're going to make just saying, give me that user, give me all of just their to-dos, give me all of just their tasks in one request, one tree request, and then that tree, just that tree is going to be brought back to you.
Right, and actually the cool thing is, this kind of a side effect. In GraphQL, you specifically have to request every piece of data that you want. So in Meteor or REST, you basically query an endpoint, right? Either it's a publication or it's a API, and you just get whatever data the server decided to send to you at that point. In GraphQL, you have to specify every single field that you want, right? So if you don't need the description of the task or something, you just don't get it. And that saves you a lot of bandwidth.
Mm-hmm. Very cool. So Apollo is going to take GraphQL. It's going to take parts of Relay, and it's going to kind of mash it together. So let's dive into this. So we have a client-side cache, right? And is that, I'm kind of confused. Is that cache GraphQL or is that Relay?
That's Relay. GraphQL specifically refers to the query language itself and the way that those queries are resolved on the server. GraphQL itself is not opinionated about any other part.
Okay, cool. So on the server side, you're going to have this query resolver, and that's what GraphQL is. Okay, very cool. So that makes sense. So what we're going to be doing is Apollo is going to be making that reactive,
Yeah.
pretty much. And basically what that's going to do is you're going to be taking those specific, I don't even know what to call them because I can't call them collections now.
Right. So you can call them in GraphQL. They like to talk about, your object graph kind of, and it sounds like you need a graph database for that, but no, you don't. So basically, you can think about it in terms of nodes and edges.
Okay.
So imagine if you can think of different types of nodes, right? So a node being just an object. So you can just say, I have a node or an object that's just a user. I have a node for my task, a node for my to-do list. It's basically just, you can think of that as one item in one collection.
Yeah.
You can think of the collection as a type of object, right?
Okay.
So if you think about all of the users in the system, that's kind of like a collection. In GraphQL, that's just a particular type of node.
Very cool. And what we're going to be doing is Apollo is going to be attaching dependency tracking on those nodes.
Yeah, so if you use Tracker on the client with Meteor, you might know what this feels like. Of course, there are some disadvantages to Tracker, but we're going to work on that. But basically, it means that when you access a certain piece of data, we're going to try to record what data you accessed so that we can later notify you when that piece of data has changed.
So that's you made it sound super simple just now, but it's actually super complicated, right? Because everything needs to know about these versions.
Yeah, so it is a little bit more complicated because Tracker operates on a single client in a single threaded JavaScript environment. This is going to operate in a multi-server, multi-client, multi-backend distributed setup, which is why we're getting our best wizards on that. But basically, so the reason that you need the versions is because of the distributed nature, and so this is one of the things that we're not as certain about yet. We're pretty certain that we can do some of this dependency tracking and validation. The exact mechanism with the versions is something that we're still researching. And that'll be actually based on, trying to go to somebody who needs this in production and saying, can this version tracking mechanism work for 1 million users or whatever. That's one of our top priorities, is de-risking that immediately. So now I'm going to talk about what my assumption is of how that's going to work.
Okay.
So the assumption is basically, let's say you access a certain document in your MongoDB database. Let's say that's a particular user. That user has an ID. So you definitely have a way of referring to a specific user, which is great. So you can access the user, and then you can record, I accessed a user with this particular ID, right? So that could be an example of the automatic generation of a dependency key, right? A key being a reference to a specific piece of data that can be invalidated. Then what you need to do is you need to figure out, is your version of this user outdated compared to the real one in the database? And for that, we are thinking of having a version number. So when you fetch the user from the database, you also need to, at that moment, figure out what the version is of that data, right? So you fetch the user, and then you go and look up maybe in the version store or Invalidation server or something. You're like, okay, this user is currently at version 7. So then when you send back the user document and the version, you send them back together to the client, and then the client keeps track of what versions it currently has. So
the version number is, there's only one version number for everything, and it's beyond the server. So it's not a unique version number per client.
No. So rather than trying to keep track of all the state of the client at once, which is something you could do, we have a separate version and dependency key for each little piece of data on the client, right? So the client can know, this part of my data is old, this other part is new, and it can know that without even talking to the application server and refetching any data. It can just send those dependency keys and get the information for itself.
So that's interesting. So without talking to the server and without really hitting GraphQL, you mean by that?
Yes. You still have to talk to some server, yeah.
So you got the separate thing, and this is like a dependency tracking server?
Yeah, so it's not exactly clear yet if that will be a separate server or something that's built into the same process, but it'll definitely be a separate component that is not necessarily even aware of GraphQL.
Cool. And the situation is then you got your data, and making a query could be expensive. And so you want to avoid that at all costs. And so you got the separate thing, keeping track of your dependencies. And depending on the mechanism of invalidation or checking, you're going to hit that and they're like, no changes, no changes, no changes. You hit that, oh, there's a change. Okay, talk to GraphQL.
Yeah, exactly. And the real benefit here, well, one of the real benefits, obviously there's a lot, but one of the really cool benefits is there's a lot of knobs to turn to tune the system. So one thing you can do is you can slow down how often you check for invalidations, right? That will just immediately make your app scale more, like at the expense of being less reactive. You can just check less often.
So you're saying that is the opposite of like having a WebSocket.
Right. So you can be as WebSockety as you like. You can have like 100% real-time updates all the time, or you can have, check every minute and like maybe update if you feel like it.
Yeah, and that's what we're having an issue with Meteor right now, where everything's connected, everything's reactive. Right?
Yeah. So there's not an easy mechanism to turn it down or turn it off entirely if you want to.
So this is what we're talking about. So more control with that mechanism.
Yeah. And the second cool side effect is once you take that as a feature of the system is you get a lot better offline data support basically for free. Because the biggest problem with offline data in Meteor is that the server in Meteor remembers what data it's sent to the client. So when you subscribe to some data, it's like, oh, I already sent that object. I'm not going to send it again. Mm-hmm. And that means that like if you disconnect for an hour, then the server forgets all about you. And then when you reconnect, it's like starting fresh. But here, the client can be aware, like even across multiple hours, it can say like, oh, I had version 27. Like, is that still the real version? And then you check and you're like, oh, it's still the real version. And like no data was sent, which is great for like sporadic connections. It's great for all kinds of stuff.
That's awesome. And that then, I don't know if we want to go into a segue just yet, but that goes into mutations. And like say you are offline and you're mutating the data, how do you resolve that when you do connect again and there's already like other versions?
Yeah, we definitely have a couple thoughts about that. Yeah.
Yeah. Interesting. And so this is showing why we need Apollo right now.
Yeah. And it's really, really cool. Like, like I said, one of our top priorities is to validate that the system can work in production. Most of the people that I've discussed it with, we've done a lot of designs and thoughts. It seems to make sense. It seems to meet the needs of a lot of the production users we've talked to as well, right? They're like, I have a problem. My problem is shaped like this. And we're like, well, it looks like it will work because you can do this and that and this dependency. And like now you get the behavior that you want.
Mm-hmm. On a previous talk, you mentioned that you guys are working with the Rocket Chat team.
Yeah. Like one of the first things we want to do is build some experiments, before we really build any actual components that you can use in your app. One way is to build an experiment where we just build a totally custom system that's very similar into Rocket Chat. And then we see like, how does this behave under like some number of users in a chat application? And then we can take that and put that into a reusable component that anyone can then download.
So we talked a little bit about invalidation and what it does, but I think like we just scratched the surface. So in your documentation about Apollo, you talk a little bit more about how we can do invalidation, and you touched a little bit on it, but what are the different ways that like something can be invalidated or tracked?
Yeah. So I think the most important thing to realize is that there's basically multiple levels of magic you can apply.
That's a good way of putting it.
Right. So at the very basic level, there should be a very easy to understand system where you just, every time you read the data or you write the data, you manually talk to the invalidation component and you specify an invalidation. So that's the very basic level, right? And you could build an app just on top of that. And I think that's what people do with systems like Phoenix, for example, right? It's good at like pushing around messages and like notifying you about stuff. So that's the basic level. Then there's basically two directions you can branch off from that. One is you could do a Meteor and you could attach a live query engine to your database. And so then what you can do is, let's say you want to be notified when a certain user object changes, you could run a live query system and have it automatically push an invalidation for you whenever certain documents change. So that will give you like 100% basically the same user experience as Meteor, where you can push into your database whenever you want, and that will invalidate the system for you. The other approach is to do that from the application. So instead of watching the database, you simply watch the mutation. So whenever the application writes to the database, it also makes sure to fire the invalidation automatically for you first. And so, or second, not first. And you can just do that by having a special database driver that has the right hooks, right? So when you call like mongo.insert or whatever, it'll know which message it's supposed to send to the invalidation server based on that operation.
And then the server gets that message, and then it goes ahead and it has it stored. Now the other clients can come and ask what version it's at, or if they have a WebSocket connected for that type of version, that will just automatically be sent to them.
Yeah, exactly. And there's definitely, there's definitely a lot of system design here about when things are supposed to happen in what particular order. Because, for example, you definitely want to make sure you only fire an invalidation after you wrote the data. Mm-hmm. If you do it before, then when somebody comes to refetch it, it might not exist. Another thing is you need to make sure that your version number is always like less than or equal to your data, in the sense that like it's okay to get new data and then have an old version number. It's not okay to have old data and have a new version number, because then you think that your data is up to date, but it's actually old.
Interesting. That didn't even come across my mind.
Yeah, so there's definitely a lot of like very naive systems you can build that I believe a lot of people might actually be using in production, like based on what I've read on the internet about these things, where they just like fire messages and they're like, oh, it's going to be fine.
Yeah.
But if you want something that's actually correct, you have to make sure that the ordering of these operations is correct every time. Otherwise, you might miss data. And actually, a lot of streaming systems, like a lot of pub subsystems, don't guarantee that you get all the data. Mm-hmm. Right? Like imagine RethinkDB. In RethinkDB, if you make a database query and then you immediately start a subscription, you could have missed a document in there, right? Maybe somebody inserted right in between you making that first query and then initiating the live query. And so you need to make sure you don't miss those.
More options for handling invalidation that the developer needs to be aware of, which that's what you talked about earlier. It's a good point to mention that Apollo is going to allow you to do any type of invalidation inside your app, depending on the data that you have, right? Like you don't need to just pick one and have to be stuck with that. Depending on the data that you have, you get to pick which one is the most performant for that.
Yeah, absolutely. Like imagine, you have 2 pages in your app, right? Imagine one is just a news feed of events, and so you want each new event to show up. And the other one is a dashboard with a summary of the last couple of days. Obviously the dashboard doesn't need to update as often as the newsfeed does, right? So the newsfeed, you might want to use this like live query approach where you identify each new thing that's coming in. For the dashboard, you might want to switch to a polling approach where you just poll every minute or something like that. And so it's important to be able to, even when you're fetching the same data, because the dashboard might be also showing the things from the newsfeed, it's important to be able to refetch them at different intervals depending on what you actually need. Yeah, I don't know if you can tell, but we've thought about it a lot.
Yes, absolutely. I ask you a question and then like you go into it and it's like, wow. And that's exciting to see like the passion that you got for such an ambitious project. Like I'm glad we got you driving it, man.
Thanks. I hope it goes well. I'm really pumped about it.
Okay, so let's talk a little bit about mutations. So you're saying that's a relay thing. Are we going to kind of take Relay's approach going forward?
So mutations are pretty interesting. It's actually one thing that we haven't actually talked about in our design docs at all. So mutations, just for background, are a GraphQL thing and a Relay thing in different ways. So the GraphQL server definitely has a list of mutations, which are basically just like endpoints that are for writing data, not for reading data. Mm-hmm. So that's part of the GraphQL specification.
Yeah. And I should probably say before we dive into it, and you said it earlier, but we can, in the context of entering this conversation, think of mutations as methods right now.
Yeah, they're almost exactly like meteor methods conceptually.
Cool.
Yeah, in the sense that it's a named function that takes a set of arguments and it returns a result. So that's great. So what Relay adds on top of mutations is very similar to what Meteor adds on top of methods, in the sense that it gives you the optimistic UI and data refetching. So this is the part where I think this is where people have a lot of trouble with Relay sometimes, because in Relay, writing a mutation can be kind of verbose, in the sense that because they don't have the built-in reactivity, which who knows if that's a pro or con, but basically when you write a mutation, you have to specify what data needs to be refetched after the mutation in the mutation, right? So you have to say, okay, I'm going to call this mutation and I'm going to do this optimistic update, which I also need to write inside my UI code. And then I'm going to refetch this data after the mutation is done. So in Meteor today, when you write a method, you just write some code that operates on your database and it kind of works out at the end. Mm-hmm. In Relay, there are a couple more components you need to write to get the same effect. And I think that in Apollo, for a certain class of apps, we can do better in terms of the amount of code that you need to write to make mutations behave the way you would expect.
Okay. And mutations are going to behave differently depending on the type of invalidation that you have coming down, right? Because like right now, methods just work because we got that live query connection that just sends down the new stuff from the server anyway.
And that's actually the crux of it, because there's nothing else in Meteor that makes it as hard to write a database driver as that part. Because so the way it works in Meteor, I don't know if this is going too deep into the weeds, but the way it works in Meteor right now is when you do a method call and you write to MongoDB, it basically figures out the timestamp at which that write happened on the database. And then the oplog watching mechanism waits until that timestamp happens to know that the method has been completed, and it can basically undo your optimistic UI changes. Mm-hmm. Right? The basic point is you need to be aware of when the entire life cycle is completed from the client to the server back to the client in order to be able to do optimistic UI.
Yeah. Yeah. Otherwise, you'll just have like a flash of like a change on your UI, and then the server is going to come in and change it. And then it will come in again and change it when the whole round trip. Okay. So that makes sense.
Right.
Now so it's like a whole new problem that we're trying to solve.
Well, right. So this is where potentially if the design works out, things could be really, really cool.
Okay.
And the really cool thing is we don't need to do this timestamp thing anymore because we have the dependencies. So I have a prototype somewhere, which is kind of wishful in the sense that it's a very simple app, which is probably why it works. I mean, we'll figure it out. But basically what you can do is from the mutation, you can return just the list of dependencies that were invalidated from this mutation. So you can say, in this mutation, when I was changing the database, I touched data A, B, and C, and you tell the client about that. And the client's like, okay, I call a mutation. That mutation on the server changed A, B, and C. And you find out about this immediately, right, when you've done the mutation. Mm-hmm. And then now the client knows exactly what data it needs to wait for to be done. And the server doesn't have to remember anything, right? So the client is now refetching its data, or it's repolling, or it's streaming, or whatever it's doing. Yeah. As soon as it sees those dependencies match the versions that the method, the mutation created, mm-hmm. and it is, right? The mutation is like, I edited this user and raised it to version 67. As soon as the client has version 67 of that user, mm-hmm. you 100% know you're done. And it doesn't rely on any timestamps, anything with a database, no backend data at all. So if that system works out, it can basically make it a lot simpler.
Okay, so say that it hit the server, and it turns out that there was a hacker on the client side, and he was doing something that he shouldn't do. The version isn't going to increase for that data because there's going to be no change because there was got denied for some reason.
Yes. So, well, if the method doesn't change anything, then you can just not send any dependencies back. So the it's a little bit different because you don't just throw away changes that were done to those dependencies on the client. When the method is complete or the mutation is complete, you throw away all optimistic updates related to that mutation, right? So every optimistic update to your client-side cache has to be associated with a specific mutation.
Mm-hmm.
And when you know that mutation is complete by knowing which dependencies have been refetched, then you throw away all the updates. So you could update any part of the client cache, regardless of what happened on the server, and then it will get totally rolled back when the client is aware that it's complete with the whole mutation cycle. It's basically the same way that it works in Meteor. Like in Meteor, you can modify any collection you want on the client, and that will still get rolled back.
Okay. Very interesting.
Sorry, it got a little bit detailed in there.
I loved it. This is like what it is because we got to get the inside scoop from you, bro.
Yeah, I mean, I should write more stuff down.
Okay, so going forward, this optimistic UI, these mutations, is that going to be, that's going to be all part of Apollo, right? That's not going to be a separate thing that Meteor is grabbing.
No. So yeah, I mean, if you're using Apollo in any app from NPM, you should be able to get all the features. There shouldn't be any features that are tied to a different system, like a build system or anything else.
Okay, so the optimistic UI that's part of Meteor right now is going to be part of Apollo, and anyone who adopts Apollo is going to be getting optimistic UI.
I mean, it's kind of like, there's so many people out there that are like, man, I just wish I could get like Meteor's data stack, but without the build tool or without some other thing. And like, exactly, this is it. Yeah. And so now we figure out, right, how do we make that relevant for our business? So that's something we're also thinking about.
Yeah. Well, let's talk about that for a minute. So right now, Galaxy, it's really simple to push up a Meteor app and it gets hosted. You can't push up anything else. Like you can just push up Meteor. It's specifically designed to handle Meteor. And just the server part, not the database part. Going forward, I'm guessing Galaxy is also going to be able to open up to host this invalidation server.
So yeah, there's a couple of parts of the system, and this is one of the things we also have yet to figure out, but we better figure out soon because
everything's up in the sky right now, right? Like we're talking like some of the stuff that we're talking about is like fairies and princesses right now, like nothing locked down.
Right. And I think, this is one of those things where we're just going to go to people that we think have the right problem. And then we're going to figure out like what they would want to pay for.
Mm-hmm.
Right. And the reason you would want to pay for it is because, while there's going to be a lot of open source code out there, we all know that not all open source projects are easy to run or operate or inspect. Not because they're trying to screw you over, but it's because sometimes those things are just hard, right? Like, not everyone can run the right caching setup easily, right? Some people can, and for those people, that's great. Or like performance monitoring tools, right? Like Kadira or something like that. Like, that's something where you pair that with the open source component and you get a lot more out of it, even though you could use it without it.
Right. And you guys are uniquely qualified to go into a project like that where you're going straight to people in production with large apps because you already have that base.
That's exactly it. I mean, that's the huge opportunity here, which is like, we're putting all these design docs out in public. Like, I guess somebody could come along and just build this thing, and then we'd be kind of, we couldn't build it.
But they don't have what you have.
I think we have a pretty huge advantage specifically just to build the right thing, right? Mm-hmm. We have a lot of connections. We have a lot of customers. We know a lot of people who are looking for just this product. And so we want to build it by going to those people and building exactly the thing they need, and definitely not building the things that they don't need. Mm-hmm. Something that we've sometimes done in the past with Meteor.
And going forward, the people who Apollo stack or whatever integrate it in their app and all that, but they don't need to bother with the DevOps because you guys are going to have a service for that. That's another unique thing. So like two major unique things that no one else can compete with you guys on.
That's right. Yeah. I guess what you're referring to as well is that, there's a difference between building an open source project and putting it on GitHub and also having the services and support and people who know how to run that stuff behind the scenes. Yeah.
That's right. Yeah. Because it's a million miles apart from, okay, use this tool to build your app. Great. Okay, now I got to build the infrastructure to manage that. And this is like pretty complex what we're talking about. Connecting the databases, getting it going, getting it working, having it talk. And something breaks down, who needs to manage that? Who needs to figure that out? Because the open source project's not going to have documentation on that or very lightly because like it's not really their responsibility.
Right. Yeah. And you might have documentation, but you might need to be like an expert in something to even get it to work. Right. Like step one of documentation is like, set up a Redis cluster. And you're like, okay. Like,
yes. Exactly.
Yeah. And I think like I said, I'm really excited to learn about how we can help people out by, for example, like, let's say that we end up figuring out that this invalidation server component has like very unique requirements because of some of these version consistency situations. Like how reliable does it have to be in order for your app to run well? And if we figure out that, there's some problems there that we can solve for people, then that's great because then you can just buy it as a service, for example, instead of having to worry about setting up yourself.
Yeah.
And the great thing for us then is, the thing about Galaxy is you have to have an entire app built in a specific platform to use it. But we're hoping that this is a thing that you can take any app that you already have and just like sprinkle it in a little bit, and now you're on board.
So people are going to be asking the natural question then. So in the future, someone can go to Galaxy to host Meteor. They can go to Galaxy to host their Apollo invalidation server. And that Apollo server could potentially not have anything to do with a Meteor app. It could have a different backend, different databases, different front ends, totally separate. Are you guys going to get into more robust hosting?
Yeah, that's just something we were actually talking about today.
Interesting.
That's how new this stuff is for us. So we're still thinking about that. I think at the end of the day, it's going to be like Apollo is front and center. And if building a certain kind of hosting into Galaxy is what we need to do to make Apollo successful, then that's what we're going to do. Right? If it's just enough to host the invalidation server and that's what people want because they want to actually host their database on-prem or something like that, then we'll do that. If people are really clamoring to just like host their entire application server written in Apollo or with Apollo on Galaxy, then we'll do that. I think it just depends on where the demand is.
Very cool. Very cool. Whew. Cutting edge.
Yeah, this is really cool. There's going to be a lot of new information in this podcast that is not anywhere else, because part of it we came up with like today and yesterday. It's cool. It's really like it's so cutting edge, just in terms of like even if there are some open source systems that have similar properties to what we're trying to do, there's just so much more on top of that to create more value. Like one thing we didn't even talk about is like performance monitoring. Like anyone who uses Kadira knows that monitoring a reactive application like has a lot of unique problems and like has its own set of requirements. Like you can't just drop in like New Relic or like whatever other performance thing you're supposed to use.
Yeah.
And so like another thing we want to do is build this from the ground up to be supportive of that kind of analysis, right? So you can know exactly when you're doing your mutations, what data is that invalidating? How is that affecting your UI? Like how many dollars does each UI component on your screen cost you in running costs? Like
Whoa.
If you remove this one widget, would you like save like 7 servers in like hosting or something?
Right. So Aeronota kind of like has his business built on this. Do you see you guys teaming up in the future or competition in that kind of sense? Or
I don't know. I think something is gonna need to work out there. One thing that I'm particularly excited about is that Aeronota and I are both, I think, on the same page with regards to the GraphQL thing, right? Aeronota was one of the first people pushing GraphQL. He has Mantra, which is kind of like an application structure that you could drop GraphQL into that to load your data. He has his own really awesome GraphQL client called Loca, I guess. And we already were having a couple of conversations on GitHub of like collaborating on some new client side stuff. So I think like, there's definitely plenty of room to work together on a lot of these problems. And from my perspective, I'm going to start with the open source bit. That's what I know. I know that we're going to need to build some GraphQL client stuff, and I think Airnoda is like one of the most perfect people in the world to work on that, because he has the perspective of outside of the Meteor building, where we can kind of get into a bubble a little bit sometimes.
Yeah.
And on the other hand, he still has the experience of like how nice using Meteor can be, and so he brings that perspective of like, we really want to reproduce that awesome experience, but on top of like a much more robust system.
That's a pretty glowing review of Airnoda. I wonder if you guys are going to have a Sri Lanka office coming up.
Oh man, I don't know. I think everyone.
If I could wink, I would wink. I can't wink.
Oh man.
Fun fact about Ben.
I don't know. All I know is, I want to talk to Airnoda as much as I can. So.
Oh, interesting. Okay. People are going to be gossiping about this conversation going forward.
Ooh.
So like in 5 minutes, we got like 5 more minutes to like wrap this thing up. I have one last question. And that is with security. So if we're not going to, so GraphQL kind of throws out the subscription publication kind of model, right?
Mm-hmm. Yeah.
Okay. So, and we rely heavily on publications for security.
Yep.
How does that look in this new Apollo age?
Okay, let me answer the question directly first for people who are trying to watch this on YouTube or something. So directly, the answer is we're going to need a new model. There are definitely people already working on different ways to do security with GraphQL. It basically boils down to securing, each individual node of your object graph, right? So saying like, is person X allowed to access like object Y?
Mm-hmm.
That's one question. Another question is, are you allowed to access specific properties of objects, right? So can I access like property ABC? Like obviously I can access a certain user's avatar, but not their like secret Facebook key or something like that. So I mean, the model there I think will actually be maybe even simpler than publications.
Okay.
Publications are simple because you know exactly where the entry point is, where you need to secure it. But on the other hand, it's a little bit more complicated because unless you filter all of the properties in all of your queries, you could definitely end up in a situation where, a publication starts publishing more data than you expected before, and like you
Right.
forgot.
Right.
So I think it'll actually
like specifically calling out the Mongo fields. You're saying.
Exactly. And in the Meteor guide, in the security section, we recommend always using the fields property to make sure you only get the fields you expect.
Mm-hmm.
So I think, ironically, we are pretty much just not recommending the allowed approach to Meteor data writing, right? So we say it's better to use a method, which is an actual function that you can call to modify your data instead of calling Mongo queries from the client and trying to validate them.
Mm-hmm.
But in an ironic twist, I think it might actually make sense to do the opposite approach for data fetching, because data fetching is a much simpler process because you know exactly what the data is. You know what properties exist on there, and so you can write kind of more declarative security rules about like, it's just like you lock the door to this part of the system, right? Like you put the data in rooms and you say like you're allowed to go in this room, but you're not allowed to go in that room. Mm-hmm. And so I think that's a model that makes sense to me, but we don't really have a design for that yet.
Interesting. Dude, that's all my questions, man. Hey, you killed it, dude.
Dude, it's good stuff. This is all I've been thinking about for like weeks, right? So, or months, maybe even at this point. So we're really trying to get it right this time.
This Apollo thing is not an easy task. There's so much stuff that it touches, and you have to get everything right so that it performs and people like it. And there's so many different endpoints that you're going to be dealing with. Yeah.
Well, so I mean that makes it sound really scary. There's some better ways.
Whoa.
So basically, we have a couple of jobs, or like goals. The first goal is get more people to use GraphQL, because if people aren't on board with using GraphQL, like our thing is it's not gonna work out, right? So that's step one. The GraphQL community is definitely growing, but it's still relatively small just because it's such a new thing. So goal number one is growing that by making it easier to use, easier to adopt, stuff like that.
Does that mean that, sorry for interrupting, simple yes or no answer. Does that mean that we're going to be seeing GraphQL integration coming up, even if it's like a simple integration with Meteor Core right now?
So that brings me to part two, which is there's a lot of individual components that are very valuable, right? We don't have to ship everything at once. It's not like we're just going to launch a product tomorrow and we're going to call it Apollo. Mm-hmm. You can expect to see a document explaining all the different ways to get data from your database into GraphQL right before you even build any code. Then you can expect to see like an adapter between SQL and GraphQL that makes it really easy to access your SQL database, right?
Yeah. And we're not even talking about reactiveness yet.
That's right. Exactly.
Okay.
And so, if you're a Meteor developer, it could already be valuable to you if you have some data that's not in Mongo to just have an adapter between your SQL database, a GraphQL client server, and then a really simple client, like even something that already exists. Mm-hmm. That can already be useful.
Or you could like attach your already existing Mongo side, but you don't want to have the reactive nature for performance. Right. So then you could tap into the same thing, but you just don't want to have that live query connection.
Yeah, exactly. So there's basically like very small incremental steps. And this is like, I think 100% the right way to build this project is to make each individual piece valuable on its own. So we don't have to like make a huge bet on the whole thing working out, right? If we get to step 8 and like, it's actually just impossible because we like totally screwed up our planning, like all the steps up until then should still be a valuable thing. Mm-hmm.
Very cool. It's like the new face of Meteor. It's like the new way to like develop stuff.
Yeah. And then, and the third goal obviously is to have a total complete system called Apollo, but that's going to come out of the first two.
This is wild. Oh my gosh. So on this show, on Transmission, we're going to now talk about Galaxy. We're going to talk about Meteor, and we're going to be talking about Apollo.
Those are the names.
Ooh, man.
We don't even have a Galaxy logo yet. Like, what's up with that? That's weird.
What is up with that?
Yeah, it seems like it would be pretty simple, right? You just like make some swirly. I'm not a designer, so don't listen to me.
There you go, like the Milky Way, right?
Yeah. This is actually over here. If you're on YouTube, this is one of the first logos we considered for Apollo, but we're not going to go with this one. For people listening, it's kind of like we tried to mash up the GraphQL hexagon logo with like a circle to symbolize reactivity, but I think we're going to be a little bit more subtle than that.
It's tempting to do like the dots and the lines, like what React has done already.
Yeah, it is.
Yeah. Well, you got a challenge. You got a design challenge there.
We're talking to Dom, so we're going to get it worked out. Dom is our designer. He designed Atmosphere and Galaxy and stuff.
Yeah, he's killer. He came from Percolate, so he's gonna lead you guys right.
For sure.
Very cool. Dude, anything else you want to like get off your chest that I didn't ask you about?
No, dude, that's perfect. You really got a lot of stuff out of me that I didn't even know that I knew. So I'm going to go through this later, and then I'm going to like turn it into a document and then save it so that I can remember all this stuff.
Oh, this is awesome. This is awesome. All right, guys. Well, thank you for joining us on this show. Go to forums.meteor.com, find the latest topic with the word transmission in it, and give us some feedback. Give us some advice. If you guys want to see something new or we're doing something wrong, we're doing something right, let us know, because this show is all about you guys. We iterate almost weekly with new things that our community is giving us feedback on, not only the topics, but also how we produce this show. So thank you very much for being a part of it, everyone.
Yeah, thanks, Ben, for setting it up.
Woo-hoo. Okay, well, till next week, guys. Have an awesome time developing amazing things with Meteor.
Transmission complete.